Hey y'all, we are going to do functions and their graphs. We're going to do more on functions and their graphs. And here we go. So, figured out how to save a graph and use it in this, so I'm pretty excited. So, here's my example. My example is that I wake up, gotta get this ready to write. Say I wake up at 8 a.m. Sorry. And I don't feel well. Say that I feel bad. Because I still haven't gotten this pin down just yet. And I have a temperature of 101 degrees. Okay, hypothetically, let's say I don't feel good. And I've got a temperature of 101 degrees. So, after about 2 hours, my temperature goes down. So from 8 a.m. to 10 a.m., my temperature is dropping. And then from 10 to 12, it starts to rise again. And then from 12 on, it just remains a constant 101 degrees. So I've got to go and see the doctor and I have to figure out what's going on. Okay, so everything I just now told you is something that we can actually show using a graph. Okay, let me see if I can write on this graph. Okay, so I woke up at 8 o'clock in the morning. And so my 8 a.m. that is when my x equals 0. Okay, so that would actually be right there at 0. That would be 1 hour later, 2 hours later, 3 hours later, 4 hours later, 5 hours later, 6 hours later, 7, 8, 9, 10, 11, 12 hours later. Does that make sense? Okay, so those are all the hours after 8 a.m. So let me go and write this somewhere else because I actually need to go ahead and write this is 1 hour after 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you get the point, right? And remember, this is with 8 a.m. being 0 because that's when this started. That's when I woke up. And my temperature was 101 degrees when I woke up. So let's go ahead and say that this is where we're going to mark our degrees. And we're going to start at 98. We have 99. We have 100. We have 101. And it keeps going up, right? Well, at 8 a.m., my temperature was 101 degrees. So that's going to be at 0, x is 0, up to 101 on my y-axis right here. Okay, so from 8 a.m. to 10 a.m. started to feel a little bit better. My temperature actually went down to 98 degrees at 10 a.m. So 10 a.m. would be 2 hours after 8 a.m. So I would go to my 2, and then my temperature went down to 98 degrees, which is right here. Let me see if I can make that a little bit, see how that writes, which is right there. Maybe when I draw the line, it should be thinner though. So from 8 to 10 a.m., sorry, yes, my temperature started going down. And then from 10 to noon, it started to rise again. So noon would be 4 hours after 8 a.m. So my x would be 4. And my temperature rose back up again to 101 degrees at noon. And then it just remained constant for the rest of the day until I was able to go to the doctor. So if we actually graph this, my temperature decreased, and then my temperature increased, and then it just remained constant until I was able to get my medication. So all of this right here is actually explaining a lot that we need to understand when it comes to graphs and functions and increasing and decreasing. If you notice, from 8 a.m. to 10 a.m., my temperature was decreasing. It was going down. So I was decreasing from 8 to 10 a.m. Now, writing this in a mathy way, what we would actually say is that f of x, that's our function, this is our f of x. F of x decreased and what we put here is the x interval that it decreased on, which was from the time I woke up for the next 2 hours, from 0 time at 8 a.m. all the way to 10 a.m., which was at x equals 2. And then what we can also say is that my temperature was increasing from 10 a.m. to noon. And the way we would write that, we would say that the function f of x increased on the interval 2 to 4. Okay. And then if you notice, my temperature actually started to become a constant. It was constantly 101 degrees from noon on. So there was a constant temperature from 12 p.m. and on. And the way we would write that would be to say that my function f of x was constant on the interval 4 to infinity. I say infinity because it's not telling me when it ended or where it ended. Okay, so that's a real world example of how you could have something that goes on in your life and you actually have the ability to graph that data. Okay, so I want to do a special note here. And my note is that there is a special name There's a special name when a graph, when a graph changes from increasing to decreasing. I promise I'm writing, y'all. From increasing to, sorry, I'm getting frustrated, to decreasing. I'm trying to figure out what the best option is for me to write with this thing. Okay, special name when a graph changes from increasing to decreasing. And that special name is a relative maximum. Because visually, if you think about it, if I have a graph and it is increasing, which means it's rising from the left to the right, and then it changes to decreasing, this would end up being the topmost part of the graph. So that's my relative maximum. And then similarly, if a graph changes from decreasing to increasing, if graph changes from decreasing to increasing, it would be a relative minima. Okay, so we would notice that if you look at our example that we did, there is not a time where it changes from increasing to decreasing, so there wouldn't be a maximum, but there is a time where this graph changes from decreasing to increasing right here. And so that would make this our relative minima. Okay. I am going to upload this video and work on this pen a little bit more. Thanks, y'all.